Now before we move on, let's do a little recap. So first we spoke about what is a program anyway, what does programming mean? It means giving the computer a list of instructions to execute. And those who actually type up these instructions are the programmers. Then we learned how throughout the ages there were different programming languages, so to speak, which a programmer would use to give the computer instructions. You could think of it like the creators of this CPU machine created along with it a whole bunch of codes which are codes that this CPU will recognize to do a bunch of stuff. The very basic code that the CPU will understand is a whole bunch of ones and zeros. However, throughout the generations, different programmers made shortcut programming languages on top of this 1 and 0 language, which will make it a bit more easier arranged and readable when we type up a program for the CPU. There are many programming languages out there, and one of them is called C++. C++ doesn't work that you type in a command and it right away gets executed. You prepare a whole bunch of files, header files and source files, and then you use a program called a compiler, which will take all these files, put them together, and produce our .exe file, which is the executable program. So all that's left to do is learn all of the code, the language keywords, and use them, type up a bunch of code, and compile and run it. So we started off by learning these commands over here. Include. Let me explain that thing a little bit better. You see, more generally, when we type up commands in our C++ files, they are commands which we would like the compiler to translate for the CPU. So basically they are instructions for the computer, for the CPU, not for anyone else. However, it is also very useful sometimes to give a few commands and instructions to the compiler himself, which eventually will help us for the instructions for the computer. So it's like there's two types of commands. There are commands for the computer, for the actual program, and then there are commands for the compiler, stuff which the compiler should keep in mind and do while it's putting together all the instructions for the computer. So one way of giving the compiler instructions is by using what is called the preprocessor commands. The preprocessor is a step in the compiling process which will run through all of your files, all of your source code and included header files, and it will look for any command beginning at the beginning of a line with a pound symbol. So these are not instructions which the actual program will do when the program is running. This is just an instruction for the compiler to do, or more specifically, the preprocessor step of the compiler to do. And in this particular case, we tell the preprocessor to include different header files which contain a lot of cool stuff which we would like to use in our program. So as you see, these instructions to the compiler will help us with our instructions to the computer. Next, we learned that there is such a thing called like a package that is inside a file, and we declared that we would like to use some of the stuff in that package. Then we learned about the magic which prints stuff to the screen. Oh wait, before that we learned about functions. Functions have a name, they have an opening brace and a closing brace, and they are a very neat way to arrange, to wrap up a whole bunch of commands and instructions in a very neat way. We're going to learn more about functions in the later videos. And every program must have at least one function, which is the main function, which is where the compiler knows that the program will start right after the opening brace in that function. And yes, so finally we learned about the printing magic, how to print stuff out to the screen. We learned the difference between printing text out to the screen, which could be just any jumble of symbols and letters, and we learned that there could also be printing different code stuff out to the screen, like calculations, or as we learned later, variables and stuff like that, which isn't going to be printed just like text, but it's going to be calculated, executed, whatever it is, because it is treated like code, not like text. Then we realized that our program executes and just shuts down right away, so we added a line or two of code which makes the program wait for us to type something in. We learned about how C++ is case sensitive, so make sure you spell all of your keywords and stuff with the correct uppercase and lowercase settings. If you make a typing mistake, you will get a compiler error. And let's go a little bit more into that thing about errors. There are several types of errors and warnings that you can get. The first one is a compiler error or a compiler warning, meaning that some error happens during the very first step of compiling. The very first step of compiling is going into each and every of the CPP files and compiling them together with whatever header they are including. Here's a little bit how it works behind the scenes. Step number 1. The compiler goes into each and every C++ file separately and compiles everything that's inside of it and any headers that it includes, and out of that the compiler makes a temporary file called a object file, which contains in it the results of compiling one single .cpp file, one single source file with all of its headers, however many headers it may include, and however many headers the headers may include, etc., etc., etc. So at the end of our program we will have two object files, one which was made from stdafx.cpp and all of its headers, and another one which was the result of the tutorial1.cpp. Step number 2. The compiler takes a seat on the side and the linker part of the compiler comes into play. The linker will take these object files, which finish with the extension .obj sometimes, obj, and it will try to link all the stuff together, especially linking them with other files outside of your project, which we will learn later they are called library files, which usually finish with .lib, and as we will learn, these library files help us also with something like including a whole bunch of functionality into our program. We'll get into that some other time. For now, let's just think that a library file is like a header file, but it's not something really that you include with the preprocessor. It is something you have to set up in the project properties. We are not linking any libraries in this simple tutorial project, so there's not really so much library linking to be done, just the linking of all of our object files together from our source files. So step number 1 was compiling, step number 2 was linking, and when linking is done we have our .exe file which is all ready to go. Then I guess we get into step 3, which is called runtime or debugging, which means basically you run your program and you test it out, you see if it works. So here's the thing about errors. You can have errors at pretty much any step of the way. You can have an error that bothers the compiler, and so you will see an error about it at compile time. The compiler will tell you, oops, I can't compile, there's an error. These are usually the easiest errors to find and fix up. Probably some sort of typo or error or something wasn't spelled correctly or something like that. So you would just go ahead and fix it up and then try to compile again. Then if compiling succeeded, then you go into the linker area, and over there you can also have linker error. Again, we'll leave that for another time about linker errors. And then finally, when we are running the program and testing it, it could happen very often that you made an error in the program, but it didn't bother the compiler because there's no compiler error, nor are there any linker errors, but something goes wrong, and during runtime your program can crash or misbehave because of something you typed wrong or something. I mean, not really typed wrong, just you probably miscalculated the effect, the result of something, which during compile time could seem okay, and it could make sense and it could work, but during runtime suddenly we realized that this piece of code could end up in making a bad runtime problem. These are pretty nasty errors, and sometimes it's very, very hard to find them and to figure out why did it crash, what's the runtime problem. Because we spelled everything right and everything linked okay, but the runtime something went wrong. More about this in the next video.